Welcome to the, so far, final part of the series about the Korg Volca Modular. I'm going to talk about connecting the Volca Modular with other Volcas. I'll show you how to use the CV input jack and what this bridge to the outer world is capable of. I'll talk about standard voltage levels and compared to those of the Volca Modular, and about some flaws that we find with the Volca Modular. Then there is a chapter about how to integrate the Volca Modular in Eurorack system. Adapter cables, common and shared electrical ground and mechanical aspects, these other things I'm going to talk about. And the last, but not the least, I'll talk about and show alternative and practical ways to power up the Volca Modular alone, as well as together with other pieces of gear, with other Volcas, but also with other synthesizers and with the Eurorack system. Well, let's get going. The common communication between Volcas simply means syncing their sequences via the sync in-out jacks. One Volca is the master, that's the one whose timing is followed by the others, simple enough. I need a patch cable here. Yes, I have it. I'll patch the master's sync out to the slaves sync in, and to the first slaves sync in, and from there eventually from the first slaves sync out to the next Volcas, next slaves sync in, and so on and so on. So the master will send the clock impulses which are to be followed to all other Volcas in a chain. Simple enough, as I said. Changing the clock rate at the master Volca changes the clock rate of the following ones. So I start the sequences, both, reducing. All right. So increasing the clock rate increases the masters increases the clock rate at the slave as well, and the other way around. Turning the tempo knob at the slave doesn't have any influence. When there is the sync cable plugged in the slave's sync in jack, but not in the master, then the sequence won't start. It won't start not won't start not before I patch it into the sync out of the master. Now this sequence starts. Even if at the masters there's no sequence running, but the sequence with the slave still follows the clock rate of the masters. Well, let me stop it. We can use the sync signal of coming from the master, coming from the Volca Modular, even inside the Volca Modular. So we don't need the second Volca anymore. Let me put it away. I have more space for the Volca Modular. Let me zoom it in a bit. Yeah, okay, and a bit more perhaps. All right, so using the sync signal even inside the Volca Modular. In video 3 of this series, I talked about the global parameters and how to switch the sync signals from every second beat to every beat. My Volca here sends sync signals every second beat. Mixing them with the each third beat clock output of the sequences unit here should make a nice rhythm, but I have to take care. The sync signals are a lot stronger. The sync signals coming from here are a lot from here are a lot stronger than signals from the sequences unit. I should attenuate them, therefore, using the utility unit before mixing them to the clock pulses from the sequences unit. Well, let me set up the patch. I use this cable here. I'll talk about this do-it-yourself cable and cables like this later in this video. So sync out, utility in, utility B in, and utility out, A plus B times C. And from the sequences unit, the output of every third beat, also utility unit in, split unit in, and the mix of both I send to the dual LPG, at first to the signal in, and let me start the sequencer. Yes. Only the sync signal. Both signals. Only every third beat signal. All right. Of course, I can feed this combination also in the gate level input of the LPG. I do so that the sound from the source module now reaches the LPG, and the gate opens to the rhythm of the combination of both signals, the sync signal and the signal from the sequences unit. So let me start the sequencer now. Only the sync, both, only from the sequences, and both again. Well, the CV in here, this bridge or gate to let the outer world enter the Volca Modular, can receive audio, triggers and gates, and all other kinds of CV signals. And from the two patch points here, I can lead these signals to any of the modules of the modulars I like to. Let me start with pure audio. If you don't need an external gate signal, well, then you can use a simple mono cable. Let me find someone here. Yeah, so, okay, a simple mono cable, like, oh, that's a stereo cable. Where's a simple mono cable? Here is a simple mono cable, yeah. And I use the sound from the Korg Volca FM this time, but I don't need to plug it into my audio unit, because I will lead this sound into the CV in of the Volca Modular. Of course, I don't hear anything. I start the sequencer. Of course, I don't hear anything because the sound comes into the CV in, but I have not yet patched it anywhere. So first of all, I take this at first the upper patch point, lead the signal into the signal in of the LPG. And now I need to open the LPG, and I can do this, for example, by patching a DC offset from the utility unit. And here we are. What we hear is the Volca FM. So I'm using the space unit of the Volca FM, of the Volca Modular, to process the sound coming from the Volca FM. So when I use a mono cable to transfer the sound, I can use only the upper patch point of the CV in unit. The lower doesn't deliver the sound, only the upper one. But when I use a stereo cable, I can use both patch points. I insert the stereo cable now. I use a terrible. I insert a stereo cable. My new teeth are not 100% okay so far. So, and now let me start the sequence. I can use both patch points, the upper one, like right now, or the lower one, like now. Let me go back to the upper one. By the way, the sound that you hear when I remove the cable is, of course, the sound of the Volca Modular, not the sound of the FM, because the gate is completely open all the time because of the DC offset, which I'm feeding in the dual LPG's level input here, the red cable. All right. Let me use another kind of stereo cable and let me set up a completely different patch. No, not yet. No more gear yet. Just a minute for something else. When I remove this DC offset, I close the gate of the LPG completely. And when I now instead start the sequencer of the modular, the Volca Modular, then the gate of the dual LPG, the level of the dual LPG opens and closes according to the clock of this of the Volca Modular, whereas at the same time, the Volca FM is running, but, and this is important now, they are not synced. You see, the sync in, sync out jacks are empty. So we have then two sequences running independently. The FM delivering the sound, and the FM delivering the sound, and the Volca Modular delivering, well, the opening and closing scheme of the dual LPG. And now I can attach different envelopes. I can use different relations of the two clocks of the two Volca machines. Let me do so a bit. Increasing release increases the opening time of the dual LPG. So I get nearly the original sequence from the FM. Let's make it slower. Let's reduce the release and increase the tempo of the original sequence here. Perhaps even a little bit of attack. Reducing attack again. Increasing the clock of the opening and closing of the gate. And I'm back to the original sequence. Making the original sequence even faster and reducing the clock at the Volca Modular. All right, and a lot more experiments are possible like that. You will have the principle so far. You will have got the principle so far. Well, let me try to make the modular Volca Modular communicate with an Arturia Keystep. I have plugged my stereo cable so far into the pitch output of what is the CV output, the pitch output of the Keystep, and I patch it into the CV in now. I take the upper patch point and patch it into the pitch patch point of the source unit. And now I need only to open the gate, and I do it again so far by inserting a DC offset. And you see it works perfectly. All right, let me remove it. The gate, DC offset. Would be nice if even the gate output of the keyboard, of the controller, the Arturia Keystep, would work together with the Korg Volca Modular. We will see. Well, I've changed it. Now this cable is connected to the gate output of the Arturia Keystep, fed into the CV in, and I have removed the connection to the patch point of the source unit and have inserted it now into the gate level input of the LPG. And when I touch a key here on the keyboard, I don't hear anything as long as I don't touch the keyboard of the Arturia Keystep. But what I'm doing now, so the Keystep is sending gate signals. Next step, of course, will be to do both, to receive the gate signal as well as the pitch information from the Arturia Keystep and put it into the Volca Modular so that I can play the Volca Modular machine completely with this Arturia Keystep keyboard, which is a lot easier to play than this one. To do so, to get pitch and gate information from the Arturia Keystep to the Korg Volca Modular, you need a cable like this one here. I've soldered it myself. It's not very nice, but it works and it's reliable. You can buy one even. It's 2 times mono to stereo. The stereo you put of the stereo, and you put, of course, into the CV in of your Volca Modular. Important is that pitch information is the right channel and gate is the left one. So I put it in now. Yeah, and then I patch the upper patch point. Let me remove this. The upper patch point of the CV into the gate, or better, to the gate trigger of the envelope to have more possibilities. And the lower one, where there is this note symbol. Okay. Yeah, to the lower one, to the pitch input of the source module. And now I can play this Korg Volca Modular completely with the Keystep. and some release, some more. Why doesn't it? Yeah. Or some attack, no release. What is remarkable is that the release time is shorter, all in all. Let me go down with the attack. Than it is with the only with the modular itself, and on the other hand, for that, the attack time is longer. We will see why this is when I'm talking about voltages and levels later in this video. But anyway, I can play this machine with my quite comfortable Keystep keyboard. Good. Before I continue integrating my equipment, I'd like to take one step back and demonstrate that we can process sound from the outer world together with the sound of the Volca Modular, of course. I use my Volca FM again, feed the FM's audio output to the CV in of the Volca Modular, and this time I patch the output to the split unit, not directly to the signal in of the dual LPG. And I could directly, I take a shorter cable. Better to be seen, I think. So I could take the carrier output of the source module and feed it, patch it directly to the other input of the split unit, but I don't. I lead it through the utility unit so that I can attenuate it, because the signal from the carrier output of the source module is remarkably stronger than the audio signal, than the audio coming in from the FM through the CV, or better said, what the CV out patch point delivers is weaker than what's the internal signal, audio signal of the Volca Modular. So I put it through the utility unit to attenuate it. And then the output of the split unit, of course, to the signal in. I start the sequencer of the FM and touching a key, lets me hear the sound from the Volca FM as well as from the Volca Modular. Of course, I could use any other way of opening the gate of the LPG. I use both sequencers. I'll use the sequencer of the modular as well as the sequencer of the FM. I have synced them, as you see, and so this is running already, the sequencer. Let me start this sequencer as well. And now I have both sounds. I can regulate the volume of both with that, with the utility unit. All right. So far, let's say the quite simple things. Now let me continue and integrate more things into the setup, integrating the modular more and more into my growing Eurorack equipment. All right, a little patch then. I turn the volume up. Quite nice. Let me mess around with it a bit. All right, let's stop it. But how did I get this patch? Well, I introduced the Neutron's LFO, patched the LFO over the Neutron's attenuator and the output of the attenuator into my Korg Volca Modular, from where I let the LFO modulate the pitch of the source unit, the pitch of the carrier, the pitch of the whole unit, of course, and then I let the sequencer do its work. The waveform of the LFO is a square wave here, and the advantage of the Neutron's LFO in this patch, the advantage over the patched LFO of the Volca Modular is, well, I have more waveform alternatives here with the Korg, no, with the Neutron, with Behringer's Neutron. Now it's time to explain a bit. The graph shows the schematic of the patch. The Neutron's bipolar LFO out is patched into the Neutron's attenuator, and the attenuator out is fed into the CV in jack of the Volca Modular, from where it modulates the pitch input of the source module. The Volca's sequencer plays the in-between well-known sequence, simply just up the scale, but the Neutron's LFO adds or subtracts CV, control voltage, from the sequencer's CV, following its own clock, which is independent from the Volca's. And because the wave of the Neutron's LFO is a square wave here, it subtracts or adds maximum voltage levels from or to what the Volca's sequencer sends to the source module's pitch control. Well, nice, but not a big deal. Why am I showing you this right now? Well, you might have asked yourself, why is there the Neutron's attenuator in the signal path? Let me measure the output of the Neutron's LFO to answer that question. So let me measure and compare now the outputs, the levels of both LFOs, the Neutron's LFO, as well as the patched LFO here at the Volca Modular. First the Neutron's LFO, sorry. All right. Okay. And we have 8.55 volts peak to peak. And that's far out of way of the signal level the Volca Modular is expecting to get. So let me compare now with the Volca Modular. I need a patch point for electrical ground. Then I have to patch the LFO patch at first, and then I take the output of the Volca's LFO and what do I get? Oh, let me change. Well, I get less. It's 3.05 volt. I mean, it doesn't matter what coupling I take. Yeah, the peak-to-peak voltage, of course, is the same. So we see the levels are completely different, and we have to talk about levels when we want to integrate this machine completely into a bigger system, for example, into a Eurorack system at all. But before I go and measure all voltages, and I've also found a way to measure the input voltage, the voltage the Volca Modular can work with when it's put in the machine. Before we do that, I have to show you something else. I've patched the LFO from the Neutron, or the Neutron's LFO, through the split unit to the pitch patch point of the source module, because I need the second output of the split unit to feed my oscilloscope. Now I change the waveform of the LFO, of the Neutron's LFO, to sine wave, and we see I have a clipping issue here. It clips at the negative sine wave. I increase the attenuator. Now we have 3 point something volt peak to peak. I don't want to go even higher. So, and it starts a little bit clipping even here. So I'm measuring the voltage, the peak to peak voltage after the CV in unit, after the CV in module here, and not before. So I'm not measuring what is coming out of the Neutron, but what is coming out of the CV in unit here. And we see clipping issues. Let me go down to 3 volt again, 3 volts peak to peak. But even with that low adjustments of the attenuator of the peak to peak voltage, we have clipping issues with the CV in. So we see the CV in unit is quite a nifty thing, okay, but it's really far from perfect. And not only that, we have to talk about levels, that we have to find out about signal levels here in the Volca Modular, input and as well as output, but also we have to find another way. I will talk about this a bit later. Well, let's talk about calibrating the Korg Volca Modular. I strictly follow the instructions of the Korg website. I've printed them out, and so I'm looking here at this paper, but it's easy enough, I can imagine. So I have to switch on the machine, but by doing so, or while doing so, I should hit or press and hold these 2 buttons, play and record. So I do, and then the key C4 lids. All right. Now I shall play the key C4 on the external keyboard here. Okay, I'll do this. Okay. Then after, no, I do it while pressing the memory button. Yeah, okay. So once again, then the key 16 will lit. Yes, it does. And then I shall play C4 once again while holding C5, 1 octave up. I'm holding the memory button, yeah. And when the record button is pressed, the settings will be saved. Okay, so let me press the record button. Okay. Pressing the play button during the operation will make the Volca restart. Okay, that doesn't matter. All right, so let me switch it off again. And let me switch it on. All right. But calibrating doesn't change the 0.5 volt per octave characteristic, the 1/2 volt per octave characteristic of the Volca Modular. It only increases the accuracy of the CV in module. I'm talking about pitch information. When coming in through the CV in module, all pitch information following the 1 volt per octave characteristic, like most or all Eurorack modules or my Neutron here, these 1 volt per octave characteristic is translated into half a volt per octave pitch by the CV-in module. Let me show that by feeding in the pitch signal from my Arturia Keystep into the source module directly, and I'll use my do-it-yourself cable from the last videos. Now here is the pitch. Here this is nothing. It's the pitch output, and I patch it directly into the pitch input of the Arturia, of the source module, of the Volca Modular's source module. Yeah, let me just hit a key. No, not yet. I need, of course, I need gate on my LPG here. I just take the minus output of the right LPG, function generator. Let me hit a key, and it's chaos. It's pure chaos. Let me remove the gate for a moment. So, what we have seen right now and heard teaches us something else. The Volca modular needs to know the meaning of the pitch signal, needs to know how far above or below 0 volt it is. In other words, the Keystep and the Volca modular need a common electrical ground, a common zero level to cooperate properly. The matter of common zero levels of common electrical ground will keep us busy also a bit later in this video, but for now I simply plug in the Volca's CV in to the Keystep's gate out. We have seen this empty cable here. I put it in here, but I don't use the outputs of the CV in. I simply make sure now by doing so, by patching this cable, that the Volca modular and the Keystep now have a common and shared ground, electrical ground. Oh, sorry, I have to patch in. I remove it, you see, and here it works. We get normal notes, we get normal sound. So we got normal sound, we got a note, we got notes, but we get notes following the half volt per octave characteristic, as the oscilloscope will show in a moment. So I insert the gate, open the gate. Yeah, this is C. And now we have a frequency of 165, 170, something like that. And now I play a key, I hit a key 1 octave up, and well, we will see. Yeah, and this is not double the frequency of that, but it quadruples it. 4 times higher, the frequency is 4 times higher when I play the Keystep 1 octave higher, and a quarter of the frequency when I play it lower, 1 octave lower. 1 octave higher on the Keystep means 2 octaves higher on the Korg Volca Modular. So it's the half volt per octave characteristic what I get. You may ask, why? Why should I want to address the individual modules of the Volca directly then? Why not making use of this translating function of the CV in module? Okay, it clips, as we saw a while ago, but as long as we use only pitch CV and gate from a controller keyboard, the CV in module is more than okay, isn't it? And yes, it is. And again, yes, I'm indeed going to use the CV in for communication tasks concerning only note information and gate signals from a controller keyboard. But my mission here is integrating the Volca Modular in a larger system. And when I say integrating, I mean integrating each individual module of the Volca as if I had bought 2 triangle oscillator modules and 2 envelope generator modules and 2 LPGs and a versatile multiple and even more, and an even more versatile utility patching module and even a space reverb individually, as if I had bought all these things individually, and instead of spending about $2,000, $2,500 for it, I had to spend only $200 all in all. I want to be able to address each of the Volca's components individually and independent from the others. And don't forget, we only have addressed the source module feeding signals into the machine so far, but I want to use each module even the other way around, using, for example, well, let's say the Volca Modular's patched LFO to modulate a synth outside the Volca. I want to send signals out of the machine too. So it's really time for measuring the voltage in and outs of the voltage standard in and outs of this Volca Modular, Korg Volca Modular, and compare them later with internet nonsense, with Eurorack standards. But I don't want to fall you asleep. I don't want you to fall asleep. I don't want to bore you with all the measuring all the patch points in different constellations. So I just attach the sheet with the measured values to this video, and you can watch them up now. There just an explanation to this sheet. The red values are peak-to-peak values, and the blue ones are direct current values. That's important to understand. Sometimes an output has both blue and red values. For example, the sequence is out. This is when I have a high frequency, a high speed, a high clock rate. Then the peak-to-peak value is more important than the DC voltage sent out by this module. And when I have a very low clock, very slowly running a sequencer, then the actual voltage level, the minimum or maximum voltage level, is more important than the peak-to-peak voltage. There are some important and interesting explanations necessary. As I told you, the red figures show peak-to-peak voltages at the outputs. The blue figures show DC voltage offset, respectively flat voltage levels at the outputs. The green figures show values which are important for the inputs. I measured these input voltages by inputting different voltage from an external machine and finding out these voltage or the voltage levels where there was no reaction yet. So the lower values, so it's the minimum value to make this unit react, or where the tested module stopped changing its behavior even if I increased the voltage level. These are the higher values, the values where nothing else happens when I go higher. The Volca Modular is powered up by 9 volt. I think that input levels of more than 9 volt may harm the machine, at least when fed in over a longer time, perhaps even when fed in over a short time. Even I did in some cases, as you see in the picture, and nothing bad happened. Even if I measured more than 9 volt input level, in some cases, as I said, for example with the modulation strength input of the source module, I don't recommend going above 9 volt. Indeed, I'm going to make a simple transfer unit which I'll put between the Volca and the rest of the Eurorack world. In my case, it's the Eurorack world. All signals going to and fro will have to pass this transfer module. It's simple, and I'll show you how to make it in my do-it-yourself diary series on this channel. This unit will secure overloads as well as translate the 1 volt per octave to a 0.5 volt per octave characteristic and vice versa. Critical inputs are the fold and the modulation strength input of the source module, because here I get different sounds even going above 9 volt. The fold input, for example, stops changing its behavior when going above 12 volt. But instead of doing so, I will rather increase the offset value with the fold knob. And it's the same with the modulation strength input. With the other inputs, there is no need to go above 9 volt because they already stop delivering different sounds, or they stop to behave differently far below 9 volt. And with the LPGs, well, there are better ways to clip a wave in the world of modular than driving the LPG's inputs above 9 volt. And what about the Eurorack world? Which standard voltage levels do we meet here? Well, Eurorack is a bit bleak, a bit poor in question of standards. Besides the power standard of plus minus 12 volt and plus 5 volt, there are no real standards. But commonly we find a range of 10 volt with signal levels, so no big deal with our 9 volt maximum for the Volca. Only the output levels of the Volca will have to be boosted in some cases. Gates and triggers want at least 5 volt with most modules, but the about 3.5 volts which the envelopes put out, the envelopes of the Volca Modular, these 3.5 volts are sufficient to trigger, for example, my Behringer Neutron's gate, and will be sufficient with most of the Eurorack modules as well. Yeah, and that's it more or less. All right. Let's do some patching to and fro between the Volca Modular and the Behringer Neutron and some of my do-it-yourself Eurorack modules now, so far without the mentioned transfer unit. But wait a minute, won't we need more than just one of my special do-it-yourself cables here? Yeah, sure. I will need a lot more of them. Let me show you how I made them, therefore. It's fiddly and difficult to pitch one of these tiny patch cables in these small inputs when there is already a lot of patched, let's say, in the neighborhood. It's really not easy to do so. But with my do-it-yourself cables here, this one, with this ending, it's quite easy because they have really a long, stiff part, and you can put them in quite easy here. All right. The downside is they are pointed and very sharp. I'll try to show you. I don't know. Here is the camera. No, it's not sharp enough. Oh, you can see it perhaps. So the tip is really pointed and sharp, and it may damage the inside of the input jacks, so that I'm quite careful when putting them in. And I have taken care that the lower blank part is as the same length as on the original small tiny cables here, so that I cannot insert them deeper than the original cables. But what are they made from, and how? The answer is fixing pins. Let me show you fixing pins from my local tailor. These nice little pins here. You see them? Oh, okay, perhaps. I hope so. And and in these fixing pins. And because I wanted the cable to have, let me close it at first, to have the same diameter as these normal patch cables here, I have made the cable from this cable here. I'll show a close-up photo, but I use only the shielding. I soldered the shielding to the fixing pin on one side. Let me show it here. I will make a photo from this as well here. So I use only the shielding from the cable, but solder it to the tip of this plug, and on the other side I have soldered the shielding from the cable right to the fixing pin, and have attached a shrinking tube to it to stabilize the whole thing. So the fixing pin ends here, there it ends, and the rest is then it's fixed with the shrinking pin. So you can solder the cable to the plug. And fix the heat shrink tube with a cigarette lighter afterwards. Or if you are well equipped with tools, you can do both in one step using a heat gun. In that case, the gun should deliver a temperature of at least 550 degrees Celsius, better 600. Otherwise, the tin solder won't properly melt and merge with the metal of the needle below this fixing heat shrink tube. Only a short test to prove that the system works, meaning that the Volca Modular transfers signals to the system, to the Neutron, as well as to this do-it-yourself Eurorack modules over here, and that it can receive signals from both. So let me explain what's going on. So we have two simple sequences, one going up and one going down at the same time. The sequence of the going down tones come from the Volca Modular. The sound, both sounds, what we hear, the upwards as well as the downwards, come from the Neutron. The Volca is not producing any sound. It's not, well, it is of course, but it's not patched to the system. So we have two oscillators, one going down, this one, and one going up, this one, and then vice versa. The frequency of the two tones, the two melodies is too much said. The frequency is modulated by the patched LFO here, or by the right function generator, and is patched through the utility unit, so that I could adjust the output level of the LFO with the knob here, and then it is sent through this cable. Oops, sorry. To oscillator number 2, this one, and the opposite, the minus, let me remove it, is sent the opposite. The inverted is sent to oscillator 1, to this one here. Once again. this cable here. So this cable coming from the utility unit, coming from the LFO, modulates oscillator 2, and directly without the utility unit it comes to oscillator 1. Therefore the sound is deeper. It doesn't go that high because it's not amplified by the utility unit. So what do we see so far? We see that signals going out of the Volca Modular without any problems work together with the Neutron. But what about the clock unit? What about the rest of the do-it-yourself Eurorack system? So this is the general clock, the central clock, giving the speed of nearly everything. I feed it into a buffered multiple, and from the buffered multiple, the clock signal goes back into this dual LPG, and into the gate input. And the signal in comes from oscillator 1. So let me insert it again. I think I'll show you a block diagram for all. Important to know, important to discover is that indeed we can send signals to and fro all across the system, and the Korg Volca Modular is completely independent, completely integrated part in the whole system. It doesn't need any special measures or any certain. It doesn't have any certain limitations. Each individual module of the Volca Modular is as if it were here an individual module of the Eurorack system. So what's left to do? Of course, the mechanical integration into the system and the power supply. And still, the question of the common and shared electrical ground, this black and red cable here going into the CV in jack comes from an unused plug here from the Neutron, from the sum out jack, which of course it's unused, which guarantees the common ground, but that's not an elegant solution, of course, blocking two jacks just for getting common ground. And the power supply, it's also not elegant having an external power supply and not like all the rest on one single power supply with one single on and off knob. And, of course, then one common and shared ground. So the question now reads, or the task is getting attaching the power of the DC of the Volca Modular to the Eurorack power supply to get common ground and to retain these boxes, these jacks, to get them usable again. Just one more patch here with the rack and the Neutron and the Volca Modular. Here I show that I can use the sync-in jack here, the sync-in jack of the Volca, to feed in the signal from a clock generator here over the buffered multiple. I use the buffered multiple here has two functions. First, the function of a multiple, of course, because from the clock the clock impulse goes into the buffered multiple, and from there to the 8-step sequencer here, as well as to the sync-in of the Korg Volca. Only that additionally I have to attenuate the signal from the clock generator before I lead it to into the Korg Volca, because it's quite huge peak-to-peak voltage level what comes out of the clock, of my do-it-yourself clock generator. Yeah, it is important that the clock generator clocks both, or syncs both, the Volca modular as well as the 8-step sequencer, because I'm using the Volca Modular's sequencer as well, and both sequencers shall be synchronized, so they get the same clock impulse at the same time. Here over the patch cable, and here over the patch cable into the sync in of the Volca. But let me at first introduce all sound components of the patch. Yeah, I start and stop the whole sound with the Volca's sequencer, as you will understand in a minute. So I start the sequencer of the Volca. Now I turn the Volca off, the volume of the Volca down, up, down. Now we hear the two oscillators, oscillator 1 and oscillator 2 of the Behringer Neutron. I reduce the volume a bit. So, with the oscillator mix, I listen at first to oscillator 2. This is oscillator 2. Then oscillator 1. Oscillator 1. Now I mix them together again and reduce the Behringer's, the Neutron's volume completely, and put the volume, turn the volume of the Volca up. So these, now you have heard all three components of the sound. Now the whole sound again, I'll fade in the two oscillators of the Neutron. Okay, then I stop the sequence, and with this I stop also the sound coming from the Neutron. So it's time for a bit of explaining the patch. The Volca sequencer modulates the pitch of its own source, of the source module of the Volca, of course. And the 8-step sequencer here from the rack modulates the pitch of Neutron's oscillator 1. Oscillator 2 here is tuned to the same bass tone, bass pitch as oscillator 1. But is modulated by the Volca's right function generator patched as an LFO by this cable here. So the function generator, the LFO, patched LFO out, goes here into oscillator 2 in, pitch modulation of oscillator 2 in. Additionally, the pulse width of oscillator 2, here the pulse width, is modulated by the LFO of the Neutron itself. So here the LFO out into the pulse width in. The gate output, here, the gate input is here, and the gate output, here, the gate output of the Volca's sequences unit opens and closes the gate of the Neutron, here of the Neutron, and activates the envelope 1 of the Neutron. The rest of the patch is quite simple. The Neutron's oscillator mix here goes into the VCF filter, and from the VCF it goes into the VCA, whose gate, as I explained some seconds ago, is opened and closed by the gate output of the sequencer of the Korg Volca, and by that it's explained why by starting and stopping the sequencer I start and stop the whole sound here. So to repeat the most important aspects of this batch. First, the Volca Synth inject can not only be used by other Volcas, but also by my, for example, do-it-yourself a clock generator or other clock generators delivering clock signals, of course. Yeah. Okay. And second, the second important thing is that the Volca sequencer, can be used to switch setups of whatever huge systems of synths on and off and modulate them. All right. This was patch number 2. You will have seen the graph as well. So let me say it again. There are 2 important tasks to fulfill: giving the Volca and the rest of the system a common electrical ground, and getting rid of the external power supply. And I have found the probably easiest and most elegant solution to both problems in one. This little piece of gear. It takes plus 5 volt from a USB port and transfers them to the needed 9 volt. And it comes with 5 outputs for more Volca modulars or Volcas or other Volca-like pieces of equipment. I'll put a link to the manufacturer down in the description. In case I forget to do so, just send me an email via my website. It takes the 5 volt from a USB port and transfers them to the needed 9 volt. So what, you may ask? Well, my Eurorack power supply, like probably even yours, delivers plus 12 volt, minus 12 volt, ground, and plus 5 volt. Soldering a little adapter is really an easy task then. And because I'm going to use even more modules, which are not meant to become modules in a Eurorack system by the manufacturer, but need plus 5 volt or plus 9 volt, I soldered even a USB hub to the little adapter. Okay, plugging the 5 to 9 volt converter in. Here it converts to the 9 volt. This comes from the power supply. This is, by the way, just the power supply then for my Arturia Keystep. So, and this comes out of the converter. I plug it in, put it here. I will do it a little bit like this. Yeah, that's better. And switching the machine on. Wow, it works. And indeed, it works like a dream. By the way, you see here over there, I have also integrated my little handheld oscilloscope. That was not a big deal, just simply soldering the ground of these cables fixed to the ground of my power supply. Once again, a little adapter, and so it doesn't matter. So this machine has always ground, and it doesn't matter whether I take the signal from a cable without ground or from a cable, from a Eurorack cable with ground. I can use the same input, but this is something else and a little bit away from the matter of only Korg Volca. Integrating the Volca Modular in a larger system, for example in a Eurorack system, a do-it-yourself Eurorack system in my case, has also mechanical aspects, of course. I've chosen the following way of mechanically integrating the machine. I made a blank plate and glued hook and loop tape on it. I don't know if it's Velcro or another brand. The local tailor, yes, the one with the pins from some minutes before, he supplied me with some meters of the tape. The second tape I glued to the back of the Volca Modular, taking care not to cover the borders of the battery compartment, you never know, nor the sweet little speaker. Well, you never know. I'm quite sure this kind of fixing the Volca in my case will hold for ages, but quite sure is not 100% sure, and so I attached an additional small plate for the Volca to sit on it. Except for this little plate, you will be able to follow a similar approach, even if you are a proud owner of one of these beautiful cases you might have bought instead of making one. Just by the way, there's a series of videos about me making this do-it-yourself modular synth here on this channel. No tutorials, but a video diary, including not only my successes, but also my mistakes and disappointments. Thank you for watching and following this little series about the Volca Modular, a series which was meant to end with this video with video 6. But it is not the end. No, there are going to be more. I've already begun to produce the next one. I won't tell you what the second series, and indeed it's going to be a series again, about the Volca Modular is going to be about. Let me leave it as a surprise for now, so that you are, hopefully, sufficiently motivated to subscribe and to click on the bell symbol to stay tuned. All right. And if you eventually had a look at my Facebook page and my Instagram account and my Twitter account and my bank, no, not my bank account. This would let you fall into deep depression and make you donate huge amounts of money, which would lead to big troubles with your wife, girlfriend, husband, or boyfriend, or all of them. Okay. Enjoy your day, Rolf.